Okay, welcome back. And in this lecture, we're going to talk about assessing clay reactivity and particularly what we call the R3 test. Clearly, it's very important that we need to assess the reactivity of clay, and this R3 test is called R3 because this stands for rapid, reliable, and relevant. Our benchmark is really to test the strength development in standard mortar according to the protocol that is in the country you're working in. Typically here we've done this work in Europe and used EN 1961. So here you see a compressive strength, the flexural strength being done and then the compressive strength. And this is what gives us these graphs here we've discussed previously, where we can see the importance of the kaolinite content, and in the LC350 mixture, we can see if we take the reference strength of the Portland cement, we are surpassing this with roughly about 40% kaolin. The idea of this R3 test is it's rapid, reliable, relevant, and reliable. And what we do is we focus on the pozzolanic reaction of the calcined clay or of the synergetic reaction between the calcined clay and limestone. And what's important is we adjust the sulfate and alkali levels so that we better reproduce the conditions that really occur within a hydrating cement. And then we have two ways to measure the reactivity, either this method by isothermal calorimetry, which is very fast, but you require a calorimeter, which may be slightly expensive piece of apparatus, or the bound water method, where you only need an oven, very, very simple piece of apparatus. It does take a little bit longer. So the design of this is we have a mixture. If we just want to look at the pozzolanic activity, we just use the mixture of portlandite and calcined clay. If we want to look at the LC3 mixture, we use a mixture of portlandite, calcined clay, and limestone. And the exact proportions you need for these mixtures are given on the slide here. The test is carried out at 40 degrees because this accelerates the hydration and enables you to get a very fast measurement. And to do this, you have to set the calorimetry temperature to 40 degrees. And then once stabilized, you can put your reference ampules in. And for your reference, you need to have an amount of water which has the same thermal mass as the paste. So the whole calculation is given here, and you can just use these values. And when you've got all this set up, you need to make a baseline. So you should run a baseline at the beginning of every test and at the end of every test. So for preparing the samples, these all have to be conditioned to be as close to 40 degrees as possible. So all the apparatus for the calorimetry, the ampoules, the caps, the pipettes should be stored in an oven for a minimum of 3 hours before the casting. Then you should weigh out your different materials, the portlandite, the calcined clay, and the limestone, weighed out and put for 3 hours in an oven at 40 degrees. The alkali and sulfate are weighed separately and mixed with water, which is also put at 40 degrees. And then we have a standard protocol of mixing at 1,600 RPM for 2 minutes, and then you put 15 grams of the paste into the ampule. So you then take the heat value after 24 hours, and we see this heat value after 24 hours gives you this very good correlation with mortar strength. The other protocol you can use is to measure the chemically bound water. So you mix up all your materials in exactly the same way, and then after 24 hours, you cut a slice from your sample, you dry it in the oven at 110 degrees until you get constant weight. And then when you have a material at constant weight, you make a heating step up to 400 degrees C. So this 400 degrees C means you measure the bound water in the calcium silicate hydrate and the ettringite and AFM phases that may have formed. But of course, you don't dehydrate the calcium hydroxide because that's what you put in the first place. And then we can see that these measurements also give us very good correlation with the strength. So, to conclude this lecture, what we've seen here is how this R3 test is a very rapid way to quantify the reactivity of the clay. If we use the calorimetry method, this can be done in as little as 1 day. If we use the barren water method, it takes a little bit longer, but the big advantage is that you only need an oven as equipment. And if you can do many tests at once, so it still becomes quite quick. And both tests really show this very good correlation with the compressive strength, which of course is what we want. So thank you for listening to this lecture, and then we're going to look at the grinding process in the next lecture.